In this session, I am taking up the reversible enzyme inhibition. Objectives of this session are: at the end of the session, the learner shall be able to define irreversible inhibition, describe different categories, give examples under each category. Now, let us take up definition. So, what is an irreversible inhibitor? What is an irreversible inhibitor? It binds tightly with enzyme. Binds tightly with enzyme. That is the one aspect. Okay. The second one is it is a covalent binding. That is most important. It is covalent binding. Okay. The binding between enzyme and inhibitor is covalent binding. Third aspect is having a covalent binding dissociates, okay, slowly. In fact, we can say essentially the inhibition is irreversible. Irreversible. Okay, the next point is inhibitor cannot be released by either dilution or dialysis. Okay, or in other way, or okay, simply by increasing substrate concentration. Inhibitor cannot be released by either dilution or dialysis or by simply increasing the substrate concentration. Okay, let us now take up various categories. The next aspect is, let us take up the various categories. Let us see. In these categories of irreversible inhibition, there are three categories are present. What is the first one? The first one is group specific. Group specific reagents. Second one is react to substrate analogs. The third one is affinity labels, or this also can be called affinity labels. The third one is suicide inhibitor. This will take up in other session. Okay, suicide inhibitor, or it can be also called mechanism based inactivation. What about enzyme kinetics of irreversible inhibition? Enzyme kinetics. Okay, the kinetics are like reversible non-competitive inhibition. Reversible non-competitive inhibition. So what is there in the non-competitive inhibition? V maximum is decreased. Okay, Km is not affected. Same type we'll see in this also. Okay, let us briefly discuss about each category. The first one is group specific reagents. Group specific reagents. Group specific reagents. The inhibitor binds with suppose what happens, it is binding. Here it is enzyme. We have the enzyme here. This enzyme, they have being a protein. This enzyme being a protein having the amino acid. These amino acids, so there are some side chains are there. And to this the inhibitor binds it. So these side chains play a crucial role. These side chains play a crucial role in substrate binding. Okay, that is the how it affects. Inhibitor is binding enzyme where at the site of the amino acids. Amino acids at what site? There are some side chains are there. Those amino acids, those side chains, they play very crucial role at the site of substrate binding or catalysis. Okay, so that is group specific reagents. The second category is react to substrate analogs. React to substrate analogs or affinity labels. These are structurally similar to substrate. Structurally similar to the substrate. Okay, but what happens? So the binding is covalent binding. The binding is covalent binding. Third one is suicide inhibitor. Or mechanism based inactivation. That is mechanism based inactivation. Okay, what is it? Enzyme reacts with the substrate. But what happens? The enzyme, by reacting with the substrate, brings changes in substrate. So what happens? It becomes enzyme and inhibitor. Okay. So there is this earlier the substrate is not doing anything to enzyme. It is not inhibiting it. But enzyme brings some changes to this particular substrate, converting it into the inhibitor. So in that condition, what happens? Through this enzyme is inactivated. That is what we call suicide inhibition or mechanism-based inactivation. This will study in detail in the next session. Okay. Now, let us take up some examples. What are those examples? The first one is for the examples of group-specific reagents. Let us take the first example. That is what is this example? Iodoacetate or iodoacetamide. What it does? It inhibits enzyme, papain, and glyceraldehyde, 3-phosphate dehydrogenase. Dehydrogenase. Okay, what it does? It binds SH groups. SH groups of enzyme. But this binding is a covalent binding, irreversible binding. Whereas reversible non-competitive, that is a reversible binding. That was not a covalent binding. Okay, that is the difference. Okay, the second one is diisopropyl fluorophosphate. Fluorophosphate. It is also known as DFP. Okay. It is also known as nerve gas. Okay. Nerve gas. Okay. It covalently binds OH group. Okay. OH group of serine residue of enzyme at active site. So through this enzyme is inhibited. What are these enzymes? Acetylcholinesterase. There will be very severe consequences, including paralysis, by the inhibition of acetylcholinesterase. Then other enzymes which are being inhibited are trypsin. Okay, then chymotrypsin, elastase, and okay, phosphoglucomutase. Let us see the mechanism. Okay, here let us see. This is enzyme. Okay, this is enzyme. This is the active site. At the active site, suppose this is enzyme. At the active site, there is a serine is present. Serine has OH group. Okay, serine has got the OH group. Okay, plus. So DIPF. Okay, diisopropyl fluorophosphate. Okay, then fluorophosphate. Then, so what happens here in this scenario? Let us see again. This is enzyme again. Okay, this is enzyme. Okay, then serine. Okay, then OH, DIPF. Okay, so this is what happens. This is active. This is inactive. Okay, that is how the mechanism looks like. The third one in this is heavy metals. Heavy metals. Okay. Lead. Okay. Then silver. Okay. Then mercury. Okay. So like this. Okay. So there is a SH groups are present. So covalent binding. These metals covalent binding. So enzyme SH group covalent binding inactivates. It is a covalent binding. Whereas heavy metals we have studied in the reversible non-competitive, that is not the covalent binding. Here it is a covalent binding, it is a permanent binding. Then the second one, Substrate analog. Some examples of substrate. Second category. Substrate analog. Substrate analog. Okay, example. That is what we call affinity labels. The first one is N-tosyl. Okay, L phenylalanine. Phenylalanine. Chloromethyl ketone. Chloromethyl ketone. This is the one inhibitor. It binds chymotrypsin. It inhibits chymotrypsin, proteolytic enzyme. It inhibits chymotrypsin. The second one is, okay, 3-bromo acetal, 3-bromo acetal phosphate. It inhibits triose phosphate isomerase. Triose phosphate isomerase, an enzyme of glycolysis. We have discussed about irreversible enzyme inhibition. Let me sum up. Definition. Irreversible inhibitor binds tightly, covalent binding, slow dissociation and essentially reversible, cannot be released by either dilution or dialysis or even by increasing the substrate concentration. Three categories are there: group specific reagents, reactive substrate analogues or affinity labels, and the third one is suicide inhibition or mechanism based inactivation. Enzyme kinetics are like that: reversible non-competitive inhibition, V maximum is decreased, Km is not altered. The group specific reagents, inhibitor binds with the side chain of amino acid of the enzyme. Okay, those side chains which are important in substrate binding and catalysis. Examples are iodoacetate, iodoacetamide. It inhibits papain, glyceraldehyde 3-phosphate dehydrogenase, an important enzyme of glycolysis. Here, enzyme is having SH group, one of the amino acid, binds covalently with the inhibitor. The second example is diisopropyl chlorophosphate, DIPF, known as nerve gas. Okay, enzyme inhibited acetylcholinesterase, trypsin, chymotrypsin, elastase, and phosphoglucomutase. Here, the enzyme is having the serine. Serine is having the hydroxyl group. Okay, it combines with the DIPF and leads to inactive complex. Inhibition by diisopropyl chlorophosphate leads to serious consequences, as acetylcholinesterase is very important enzyme. Okay, then the third example is heavy metals. Okay, lead, silver, okay, mercury. Again, enzyme at the amino acid, SH group is there, the heavy metal binds it, the binding is covalent binding. Then, second category, substrate analogues or affinity labels. Inhibitor has structural similarities with the substrate, but the binding is covalent binding. Examples are N-tosyl, L-phenylalanine, chloromethyl ketone. It inhibits chymotrypsin, proteolytic enzyme. Okay, then second example is 3-bromo acetal phosphate, inhibits triose phosphate isomerase. Okay, then third category is suicide inhibition or mechanism based inactivation. Here, enzyme combines with the substance. Enzyme brings changes in substance and converting it into inhibitor, that is irreversible binding. It inactivates the enzyme. These are various aspects of irreversible enzyme inhibition. Okay, thank you very much.